Properties of addition of integers. Now let us discuss what are the properties while you are doing addition of two integers, two or more integers also. So the first property is the closure property, which says that if you are adding any two integers, your sum will belong to the integers. That means, let us take example, if you have two integers, let's say 2 plus 1. The answer, that is 3, is a integer only. Similarly, if you add minus 2 plus minus 1, what are you going to get? Minus 2 minus 1, that is equal to minus 3, which is again an integer. So that means adding up any two integers is giving you a answer which is an integer only. We can have different examples. Let's say minus 2 plus 0, you would get minus 2. If you add minus 2 plus 1, you would get minus 1. Now please pay attention, you are adding two integers. Here I have added a negative integer with 0, I got a negative integer. I added a negative integer with a positive integer, I got a negative integer. So these are the various cases possible for addition of two integers. So the property, the closure property is satisfying for all the cases, right? No matter which type of integers you are adding, you are always going to get an integer on adding two or more integers together. The next is the commutative property. In the commutative property also we have already done so many commutative properties earlier that means the order of addition is not important. Whether you add first integer with the second integer or you add the second to the first one, it will not matter at all. Let us discuss that. Let's say I am adding minus 2 plus minus 1, right? Whereas on the other side I want to add minus 1 and minus 2. Now I have reversed the order of addition, right? So let us check the answers now. Over here we would get minus 2 plus into minus becomes minus 1, and here we get minus 1 plus into minus 2. So here we get minus 2 minus 1 as minus 3 and minus 1 minus 2 as minus 3. That means this is also coming out to be true, right? So for any two integers addition or any 3 or 4 integers addition, the order of addition is not important. That means you can add up any two integers first and keep on adding the rest of them step by step. The next is the associative property. Associative property tells us to add any two integers first and then add the third one, as I just told you. So let us check for this one also. If we want to add 1 to the sum of 2 and 3, what would we get? We should be getting the same as we would add 1 and 2 first and adding 3 to it. Let us check. 1 plus 2 plus 3 gives 5. 1 plus 2 is 3 and 3. So we get 6 equal to 6. Here also we are finding that the addition of integers is associative. The addition is satisfying closure property. It is commutative as well as associative. Moving on, the next we have additive identity. Now additive identity means you are going to add integer to 0 or 0 to any integer. As we have discussed, 0 is a neutral value and it represents a null value, that is nothing. So when you add nothing to an integer, what would you get? You would get an integer only. And if you add an integer to nothing, right, you would get that integer. For example, there is a vacant box lying with you and you want to place some say items into it. Say you have put in your shoes into it. So when you put your shoes into a empty box that had 0 value, and now you have put your pair of shoes, that is 2 shoe into that. So now what do you have? You have pair of shoe in that vacant box, right? But if you are having a box full of shoes and you want to add nothing to it, what would happen? When you add nothing to it, your box full of shoes will remain as it is, that is the box full of shoes only. So that is how is the case for additive identity. That means whether you add 0 to any integer or you add 0 or you add any integer to 0, your answer is going to be the same, that is that particular integer. Let us check this now. I am taking minus 100 plus 0, and if you do 0 plus minus 100, let us check for both the cases. Minus 100 plus 0 is going to give you minus 100 because 0 added to anything is the same thing. What about this? You would do 0 plus minus is minus 100, and when from nothing minus 100 is subtracted, you would get minus 100. So here you can check that on adding any integer to 0 or adding 0 to any integer, you would get the same integer. Now the next is, or the last property for addition of integers, is the additive inverse. This is very important property. It's very simple to understand. Let us take one example before moving on forward. What would you add to 2 to get a 0? If I ask you how much or what should be added to 2 to make this whole thing come out to be 0, that means definitely you will tell me that ma'am, you should be adding minus 2. Why? Because here the 2 plus minus minus 2 will give you a 0, right? That's the case. If I ask you what should be added to minus 14 to get a 0, you would tell me it would be plus 14, right? So that means these values are telling us if you are adding any integer with some sign, what will be the inverse for that integer? The additive inverse for that integer would be that integer but having opposite sign. Over here I had a positive integer. What should be added? What should be the additive inverse of 2? The additive inverse of 2 is 2 only but having a opposite sign, that is minus. What is the additive inverse of minus 14? The additive inverse of minus 14 is 14 only but having the opposite sign plus. Here we had minus, here we are going to have a plus sign. For positive integers we are going to have a negative sign in their additive inverses. So that was about the additive inverse. That means this property over here is clearly telling us when you add up an integer and its opposite and the same integer with opposite sign, you are always going to get 0. That is what I have proved over there. So we can write that 2 plus minus 2 is giving us 0, or you do minus 2 plus 2, you are also going to get 0. That means what is the additive inverse of 2? Additive inverse of 2 is minus 2. What is the additive inverse of minus 2? It is 2. So that means the additive inverse for any integer is that integer only but having the opposite sign.